Just now, I just
All right.
pressed the magic button. So let me check if it worked. I should see us on YouTube. I don't know. Okay, we're definitely live. Yes. So, hello everyone to this new interview of the series 2 Weeks of Databases. Today we have Richard Hipp, the creator of SQLite. So, hello, Richard.
Hello, Federico. How are you today?
Very good. And you?
I'm doing very well, thank you. A little bit
Great.
cold. The weather is cold and rainy. When is spring going to come?
Same in London, actually. In which part of the world are you,
I'm
actually?
in Charlotte, North Carolina.
Oh, okay. How's the situation there?
Oh, the COVID thing?
Yeah.
Hadn't really noticed. I mean, of course, everything's closed by order of the governor, but I've been doing this programming thing for decades. This is nothing new to me. I mean, old geeks like me, we're old hands at social distancing. That's what we've been doing since the 80s, right? I mean, the only thing I've noticed is I can't buy toilet tissue. I mean, it's
Actually, you're not the first person who says something like this.
yeah.
Yeah. Well, it's okay. Good for you. So, do you want to maybe start this interview by talking a bit about your background?
My background.
Yeah.
Okay, well, I'm an odd duck. I went to I went to I don't know, how far back do you want to go? I'm an old geek from way back. I bought one of the original Apple IIs, just the
Oh,
motherboard, serial number 508. Just the mother.
wow.
Built my own power supply and keyboard from parts I bought at Radio Shack, and taught myself to program. That was back in the 70s. Didn't do anything for computers for years and years. Took a master's degree in electrical engineering. Went to work for Bell Labs, and they as soon as I got there, they handed me a copy of K&R and put me on a VT100, not a VT100 emulator, mind you, a real VT100, and said, "Hey, learn to do this."
Wow.
So I picked up programming and did that. Went back to graduate school, took a PhD in computational linguistics. Have never in my life had a single course in database technology, and so avoided academia. Started my own business, was solving hard problems, and then needed a database engine that none of the existing ones were doing what I needed to do. So I thought, hey, I'll just write my own. How hard can that be? Harder than you'd think, it turns out, but it's worked out well, and so here we are. I don't do. I used to do a lot of bespoke software development. I mean, that's what I did for years, but now it's just we support SQLite. That's the job. Loving it. It's been a great run. We hope to keep doing it for decades ahead.
Wow.
It's kind of an unusual story.
It's a lot of time. Just to let you know, you are talking with a very passionate person about abandonware and old computers.
Oh, really?
So I'd like to ask you, how different is a modern programmer from a programmer of the good old times?
I think it's a totally different thing. This has come up for me. Excuse me.
Yeah.
Trying to, I sometimes give talks to undergraduates and trying to explain to them, well, what, somebody that's new to this, how to explain what to do. And with me, I started learning about computers. My Apple II had a total of 4K of RAM, and that included the video RAM. Okay, that was the whole thing. All right, I'm just going to let that ring.
Okay, no problem.
But with just 4K of memory, I could with just 4K of memory, I could understand everything that was going on in that computer I could understand everything that the computer was doing. There was,
Yeah.
but now, with the smallest computer having 4 gigabytes of RAM, there's no way that somebody coming into this now can understand everything that's going on in that computer. So I started very simple, and as the computers became more and more powerful, I kind of grew up with it. And so I tend to forget how much there is to know. I've accumulated all this knowledge over the course of 4 decades, 5 decades almost. And how do you learn that in 4 years of university? I don't know. You have to pick and choose. You've got to, some things you just have to take as an article of faith. Yeah, this works. Believe it. But there's no way to learn it all in just 4 years. And with so much going on inside the computer, who can understand everything that's going on inside the computer? Yeah, so it's a totally different world. Totally different world.
Yeah. Actually, nowadays, you don't even know if something that happens is actually happening in your laptop or in your phone or in some remote computer nothing about.
Oh, yeah. Or it could be happening in the CPU that's running in your keyboard. It's
just,
you don't know.
Yeah. So going to the topic of the interview, can you maybe explain what SQLite is for those persons who maybe never used it?
Right. Okay. So we were talking before we went live. I'm the odd duck in your 2-week series of lectures because everybody else is talking about client-server database engines, and that's a big problem. It's an important problem. Definitely something that people need to pay a lot of attention to, where you're storing your data in a data center on a big machine that's in an enclosed room somewhere in conditioned space. It's a centralized repository of data. SQLite, that's not its mission. Some people actually use it for that, but that's not really its mission. We're about storing data locally. So most database engines, they're in the data center. We're storing data at the edge of the network on your device. SQLite is the dominant database engine in mobile devices. It probably is storing your bookmarks in your web browser. I'm sure it stores it in all the data for the configuration settings for most of your applications on your desktop, that sort of thing. The only thing that connects it with all the other databases that you're studying is the fact that it speaks SQL.
Yeah.
So unlike the systems you're used to working on, I mean, you're a MySQL expert. If you've got a MySQL installed on the system, where is the data stored really? Do you know the names of the files where that's actually stored?
Yeah, I do.
Okay, you're an expert. Okay, but most people don't. It's on the machine. When they say the database, they're talking about a box back in the back room. Whereas with SQLite, a database is an ordinary file on disk, one file on disk. So you can write to the database and then send that database as an email attachment to your buddy. It's an SQLite database has more in common with a zip archive than it does with because a zip archive, when you think about it, is really kind of a key value database, isn't it? The key is the file name, and the data is the content of the file.
Yeah.
So SQLite is kind of like a really enhanced zip archive because, well, one, it's a relational database. It stores, you can query it with SQL, and it's transactional. But also you can store little tiny bits of data, Booleans and integers. You don't have to store an entire file all at once. And you have indexes and all of that other nice stuff as well. So so SQLite is more like a zip archive than it is MySQL. It's not the one of the slogans we often say is that SQLite does not compete against Oracle. SQLite competes against fopen.
Oh yeah.
Yeah, because the purpose of SQLite is all these things where people would normally, they're writing an application, they need to store some data locally, and they'll fopen or whatever you use for the language of your choice, and write something into a file, and maybe it's JSON or XML or something like that, and then you're storing some data there. And I'm thinking, no, don't do that. open an SQLite database instead. So our competition is fopen with XML and JSON, not MySQL and Postgres. They're not our competitors.
Yeah, I get it. Actually, I work with several databases, but I'm glad that you mentioned MySQL because there is something I would like to highlight. Despite what you said, until maybe just a few years ago, one could probably say that SQLite supported more SQL than MySQL.
Well, yeah. Well, okay. Maybe still so. I don't know. I don't keep up with it that much. When I was originally writing it, I tried to make the language of SQLite as compatible with as many systems as I could. It has actually some MySQLisms in it, like SQLite. You can use double quoted strings instead of single quoted strings like you're supposed to. And does MySQL still do that? I know that was a big thing in MySQL 3. Whatever. In fact, I think in MySQL version 3, all strings had to be double quoted rather than single quoted. Is that the case? And they only introduced single quoted strings with MySQL 5. Of course, this might be before you started programming. I don't know, Federico. You're a little younger than me. Yeah, we've just over the years, customers. We make our, because SQLite is in the public domain, but we make our money by selling support, and people come to us, customers come to us and say, we need this, that feature. And at one point, Oracle was actually one of our customers, and they said, oh, we need recursive queries. And so we added common table expressions to SQLite. And this is before MySQL had it. And we've got things like save points. Do you have save points in MySQL?
Yeah, you have them.
Do you have partial indices?
No, you don't have them.
Oh, so they were there. So SQLite's had partial indices for years. We did that for Expensify.
Yeah.
Okay. So people come to us, they ask for these features, and we put it in because it's interesting when I talk to other database people. They're kind of two schools of database people. I mean, there's one school of thought where they're really focused on the storage engine and getting lots of concurrency and scaling out and having big data, and that's a tough problem. Okay, I'm not trying to diminish that problem in any sense. It's a very important problem. It's important people work on that. But a lot of database people, that's what they're really focused on. My passion, though, is more on the query language. I think that's the real key aspect of SQL. A lot of just line developers, people who are using SQL in their daily lives, their view of SQL, it's just the wire protocol that goes between my application and the MySQL server. That's how they think of SQL. They don't really understand the power of the language and how it can be so beneficial to application development. The cool thing about SQL is, I mean, you're working on an application and you're coming close to delivery, and suddenly discover a performance problem. What are we going to do about this? And you work around with it, and you find, this query is taking too long. And with SQL, and if you're doing this with a key value store of some sort or a document store of some sort, once you find the problem, you're going to have to rewrite some code. You're going to have to revisit your algorithms and find a new way of doing this and maybe store data a little bit different. With SQL, you type create index, and your problem is normally solved. And you don't have to recompile your application. You don't even have to restart your application. It just suddenly starts running faster. And that's really an amazing capability.
Yeah.
And I, in talking to people, I find there's a lot of people don't grok that. They say, I know SQL, and what they mean is they know how to query to write a simple select statement, a simple insert statement. But, writing a complex joins with nested subqueries and stuff is not something that they've really faced. And And there is a learning curve there, but it's one that everybody needs to go through because it really opens up entire new horizons. And I'm not speaking of SQLite only. I'm talking about all of the SQL database engines: MySQL, Postgres, SQL Server, whatever it is you're using.
Okay, great.
I have really gone off of your original question, didn't I?
No. It's
I'm taking over the interview.
No, your answer is great. Actually, I care about both aspects of databases: the language, which is actually the purpose, but also the underlying things, because it's where you have to find performance problems and so on. So I will try to talk about both during the interview, if you don't mind.
Not at all.
Great. We have a question from DB Demon, who asks if there is a NoSQL API for SQLite.
What OSQL? I'm not. What?
NoSQL API.
So like a key value store. There is kind of. Is that what he means by that?
Yeah, if DB Demons can specify, maybe. But I suspect he means more.
Is there a C API that you can use to directly access the database without using SQL? Sort of.
Yeah, probably.
We have the ability to read and write into blobs using just C language. You never have to do any SQL at all.
Okay.
But you have to do your create table and using SQL. So no. No.
Okay.
We don't expose the low level any low level interfaces directly to the storage engine, and that's a deliberate thing. One of the promises we make is to maintain backwards compatibility. Our goal is to support SQLite through the year 2050. So we've got 30 years of support ahead of us. And so a big part of my job is to jealously guard these interfaces so that we can change them. If I publish an interface to the underlying storage engine, that means I have to support that thing for 30 years. I don't want to do that if I don't have to. So I'm reluctant to kind of open those things. Now you can go in and figure out what the interface is yourself and try and use it if you want to. But then if I change it next week, no tears. Okay.
Yeah. Interesting. Can you talk about virtual tables?
Virtual tables.
Yeah.
Yes. This is a feature. I guess it's similar to foreign tables in Postgres. It's the ability to, a real table is actually data in your database file. A virtual table is instead of actually going to the database file to capture the data, it calls methods on an object that you provided. So maybe the best way to explain this is by example. And one of the best examples I know is a project out of Facebook called OS Query. So if you can just do a web search for OS Query and find this thing. And this is they took SQLite and they added a bunch of virtual tables that access operating system properties as if they were SQL tables. And so they have a table that is your process table, basically the output of the PS command. And there's a table that accesses all of your network connections, or at least the data about your network connections, the netstat command, basically. And there's another table that is your user database, etc password. And so you can write an SQL query that's a join against those three tables that says, show me the names of all users who are running programs that have open TCP listening open TCP ports on port numbers less than 1,000 or something like that. And it's really amazing. They've got dozens or maybe hundreds of different tables that you can query your operating system as if it were SQL. It's a really cool thing.
Yeah.
Another thing that we do, I was talking about this earlier. If you think of a zip archive, that's kind of a key value database, isn't it? We have a virtual table that will access both read and write as zip archive as if it were a database. So if you take the SQLite 3 command line tool, which is just the interface that most people use when talking to a database file, and instead of pointing it at an SQLite database file, you point it at a zip archive, it will open that zip archive as if it were a database, and you can run queries against it. And you can do things like ask, show me all the files bigger than 20 kilobytes or something. A fun parlor trick I like to do is like an open office presentation is really a zip archive. Did you know this? So I'll be giving a talk using open office, and I'll shut down the talk, and I'll bring up the open office presentation file in the SQLite command line tool, and it looks like a database, and I can query all the entries in there, and then I do an update that changes some text in there, and then shut down SQLite and bring up the presentation, and sure enough, it changes it in the presentation. Not the suggested way of editing your open office presentation. Like I say, a fun parlor trick. You can do things like that. So virtual tables are a very powerful mechanism. We originally wrote it for the purpose of providing support for full text search.
Okay.
Back before HTML5, Google approached us and said, hey, we need they had this thing called Google Gears. Do you remember Google Gears?
Yeah.
It's a defunct idea now because it's been overtaken by HTML5, but they needed a full text search engine in there, and they came to us and said, can you add full text search to SQLite? And I recognized that there's no way we were going to get that interface right on the first attempt. Okay, it just wasn't going to happen. And I didn't want to build it into the core and then be compelled to support it for 50 years. So I came up with this virtual table idea and just loaded it as a virtual table. And so that way we can have these plugins that do interesting things like full text search or R-tree search or that sort of thing without having to build it into the core.
That's interesting. But I would like to ask, if one wants to develop some virtual table for full text, will they have to, well, actually, how much will they have to develop? For example, will they have to implement inverted index and stuff like that?
No. So the latest edition of the full text search engine is called FTS5. We numbered them. There was 1, 2, 3, 4. Now we're on 5. 3, 4, and 5 are still supported. 1 and 2 are just historical relics.
Okay.
But the latest one is 5. And you just say create virtual table. Have to use the virtual keyword. Give it the name of your table, and then using FTS5, and then give it arguments, which are the names of the columns that are going to be in your full text search thing. Okay. And then start putting data into it, and then you have some magical query properties. You can do select star from table name, where column, name your column, matches, and then give it a full text search pattern, and it gives you all the rows from that match that pattern. So it's handling all of the inverted indices and all that for you behind the scenes. It's fully automatic.
Interesting.
So it's like a separate table. It's not an index. Like you don't say create full text index on an existing table. You can do that, but really you're creating a new table that has this virtual or this full text search property in it.
Okay.
It's a little different.
Then I would like to ask you something about the low level again, if you don't mind.
I don't mind.
Can you talk a bit about the locking model of SQLite, and actually
we get a lot of grief
why
about this.
SQLite has a locking model?
Okay, well, so understand, look, all of the other database engines you're familiar with, they have a server. Okay, even with MySQL embedded, there's a server. It's just that in that case, the server is running in a separate thread rather than in a separate process. There's always a server that's persistent and running in the background, and in those cases, that server is there and it can coordinate concurrent access for you. But we're completely serverless. There's no separate thread, no separate process. When you call an SQLite API, That's just a subroutine call, and the subroutine runs and it returns. And once it returns, it's done. There's nothing running in the background to take care of stuff.
Yeah.
So the only way for us to manage we don't have a separate server to manage concurrency. The only way we have to manage concurrency is whatever locking primitives the operating system gives to us, which is going to be file locks. And if you've got one process accessing an SQLite database and you're in the middle of updating it, and you haven't committed the transaction yet, but you're holding some locks because you've written part of your transaction into the file, and then you call exit, or somebody else sends you a sig kill, or the power goes out, or whatever, your process shuts down, and the operating system automatically drops all those locks. And so because there's not a server there to coordinate that recovery, that's a little bit of a problem. So it really comes down to the fact that there's no server there to manage the recovery. We have to use these locks. Now, and that does limit our concurrency. But on the other hand, I mean, how many concurrent users do you need for the contacts database on your phone? I mean, do you have 100 different processes accessing that database at the same time? I don't think so. How many concurrent users are there on your iWatch? Really? and that's our use case. But I mean, we do support multiple simultaneous readers and one writer all at the same time.
Okay.
But you can't have multiple simultaneous writers because there's not a good way of doing that without having some other persistent process there serving as a referee to keep everybody in line. There's no way to do that sensibly. You could do it in theory, but the overhead involved would make everybody disappointed with the performance.
Okay, interesting.
So it's solving a different problem. I mean, if you need high concurrency, you need a server, bottom line. But if you're just writing, if it's the database that's storing the bookmarks for your web browser, how many different processes are writing to that database at the same time? Seriously.
I suppose one.
And if you do have multiple processes, can they not take turns? Because SQLite will handle all the locking, and if you try and write and somebody else is doing it, it'll say, okay, well, we're busy right now. Can you try again in a few milliseconds?
Okay.
And then it'll do it. So it works okay, but it is a problem, and people don't understand that because they're used to thinking of the client server model, and we're not client server. There has lately arisen some confusion in terminology because a lot of people are selling so-called serverless databases in the cloud, which are really, these databases really actually have a server running behind the scenes. But when they advertise a serverless database, that means that we, your service provider, are providing the database server for you. Okay, you as the user don't need to mess with it. We're managing the server for you. It's not that the server doesn't exist, it's that you don't have to deal with it. And that's the new marketing definition for serverless. It means you don't have to mess with the server. We're going to do that for you in exchange for your monthly fee. With SQLite, it truly is serverless in the fact that there is no server anywhere. So a little different.
Yeah. I remember a brief exchange of messages on Twitter where Peter Zaitsev posted a link to a page of documentation of SQLite, which basically said SQLite is serverless, and he said, so is this actually serverless? And I commented like, yeah, but I suspect this page is older than the buzzword.
Yes, I actually amplified. I remember that. Was that you on that Twitter thread? I didn't realize that. I remember Peter was involved with it. But yeah, and I have attempted to clarify that page somewhat now that the confusion has arisen. I had the term first. I've been saying serverless for over a decade before the marketing people came up with that word. So First dibs.
So, to remain on the low level, with last question on the low level, just can you tell us a bit about how you implemented transactions in SQLite?
In the 30 minutes remaining, no, it's way too complicated for that. And I need a diagram. I need a chalkboard or a marker board or something to explain that. I'll try. There's a web page about it on the website. There's two ways. The original way is using a rollback journal. So basically, as you start to make changes, you first write the original unchanged content of the database file. Well, let me back up a little bit here. An SQLite database is a single file that consists of one or more pages. And a page can be any power of 2 between 512 and 64K.
Okay.
Usually it's 4K, but it can be any power of 2. So, and a database file is just a sequence of pages. And when you start modifying the database, you're modifying entire pages all at once. And so before modifying any page, it makes a copy of the original unmodified page into a rollback journal. And then once it has all that in the rollback journal, and then it f-syncs that rollback journal to disk, so it's safe in case the power goes out. And then it goes and starts writing into the original database file. So if power goes out at any point, the next guy that comes along, he opens the database and says, oh, there's a rollback journal here. I better play back that rollback journal and restore the database to its original content. But assume everything goes well and there's no power lossage or crash or anything. Once everything is written to the database and you f-sync the database, make sure it's securely on persistent storage, it then unlinks the rollback journal. And that's how the transaction commits. Now that's rollback. It's kind of slow because it involves multiple f-syncs and you have to unlink a file. The other way is a write-ahead log. And this is much faster and better, but it has the requirement that there's a bit of shared memory that all processes have to share in order to access the database. And so it doesn't work if you're accessing the file over a network file system. So that's called wall mode or write-ahead log mode. And in that mode, it writes the changed pages into the write-ahead log. And then f-syncs it to the write-ahead log, and then that commits the transaction. And then other readers, they know to consult both the original database file and the write-ahead log and pull whichever the most recent version of each page is. And the bit of shared memory is there as a hash table so that all processes can very quickly locate the changes that are in the write-ahead log. And then periodically you have to go back and checkpoint that write-ahead log back into the database file. But that can be done with a background process. It happens automatically if you don't have a background process, or you can do it as a background process if you want. But it's much faster and it gives you better concurrency. There's less f-syncing and so forth. So there's two different transaction control systems. From the application's point of view, our transactions are serializable. Most of your client-server database engines don't do serializable transactions. Our transactions are serializable because they're serialized. We only allow one writer at a time.
Okay.
So it's easy for us. Doing serialized transactions with multiple concurrent writers is more challenging, shall we say.
Great. Okay, actually, hopefully there are developers following us that maybe need to use SQLite, and possibly some of them are concerned for some reason about performance. So can you suggest to them good practices to follow or bad practices not to follow?
Right. Well, all right. So the first thing is to understand that SQLite is a different use case from MySQL or Postgres. I mean, you should not be pondering, well, do I use Postgres or SQLite? This has to you either want an embedded database or you want a client server database.
Yeah, of course.
But still, there is some amount of overlap. For example, the SQLite website itself is database driven, and it of course uses SQLite. Duh. And it works fine. I mean, it's not we don't have to run at Facebook scale. The website gets maybe 10 hits per second or something like that. And not all of those actually have to consult the database. So that's not a problem.
Okay.
And so kind of the rule of thumb I have is that with SQLite, is an appropriate thing to use if the data is stored on the same physical machine where it's being used. So SQLite does not really work well over a network. And if you think about it, a relational database is acting sort of as a data filter in the sense that it's reading more content off of disk than it's actually returning to the application. Maybe orders of magnitude more content is coming off the disk than is going to the application. So if your data is separated from your application by a network hop, you want to minimize the amount of traffic going across that network hop because that's going to be a bottleneck. And so you want that network hop to be on the link that has the lowest data rate. And that's going to be the link between your application and the database server or the database engine. So if you're running MySQL, that's easy. You put MySQL on the same machine that has the disk drives, right? But if you're running SQLite, the SQLite engine has to be linked with your application because it's just a subroutine. That means that the link that separates you from your data is the actual physical data link, and you're sending a lot more content across that. So SQLite is not necessarily recommended for a network file system because you have all this additional traffic across the link. A better solution there would be to put a server on the remote machine where your data lives and just have the server send the actual content you need across the data link. So rule of thumb is if your application is separated from your data by a network, you should use a client server solution. SQLite's also limited in its file size. I think it supports databases up to 140 terabytes.
Well, it's a lot.
Yeah, but some people have databases bigger than that. And for that matter, SQLite wants to put all of the data in a single file on disk.
Yeah.
So if all of your data is going to fit comfortably in a single file on disk, then SQLite could work for you. If you've got more data than you're comfortable putting in a single file on disk, you need to consider another option.
Okay.
And so, but there's a lot of problems where SQLite's appropriate, and where people mess up is they said, well, I don't really need the server because my data's local and it fits in a single file. I'm just going to write a bunch of JSON into a file and deal with it myself. No, use SQLite for that. It's much faster and it's going to work a lot better. You're going to save a lot of time and you're going to have fewer bugs.
Great. Just a brief thing. You mentioned that the website is powered by SQLite. I believe that actually SQLite the driver also comes with default PHP distributions, right?
I think PHP bundles SQLite. Yes, I think Python also bundles SQLite.
Okay. Great.
Yeah, a lot of languages bundle it as well, and it usually comes built into your computer. It's definitely built into Macs. Macs use it for everything. It's built into Windows. There's a win SQLite3.dll file that's in the system folder in Windows. Windows uses it to boot up somehow. I'm not sure how that works, but they're using something. And yeah, it's already in your computer, so you don't need to install it if you don't want to. You can use the one that's already there.
Okay. Completely different question. Who develops SQLite? I mean,
Me and Dan.
You only?
Well, no, I've got a lot of help from Dan Kennedy and Joe Matashkin. Right now we have 3 committers. Those 3. Okay. Joe deals with the Windows side of things. Joe is we love having Joe because Dan and I are Unix people. And so we'll be in a meeting with people and with Windows people, and we'll be talking, and they'll be saying stuff, and Dan and I will be nodding approvingly, and then we'll go offline, and we'll turn to Joe and say, Joe, what did they say? And Joe is bilingual, so he can translate Windows into Unix, and that's immensely useful. And he'll explain to Dan and I what they just said. Oh, yeah, that makes sense. Okay. So Joe deals with a lot of the Windows aspects of things, and maintains the system.data.sqlite port for us.
Mm-hmm.
But most of the core hacking is done by me and Dan, and that's it. So we have two committers.
Okay, great.
Yeah.
Great.
So
great.
we're still hacking too. You know, a lot of your other guests, I guess, they're in kind of a management role, right? We don't have management roles here. I mean, I theoretically should be the manager, you know.
Okay.
But I'm a really awful manager, and so we just say, well, we're just not going to do any management. We'll just let it go.
Okay. Okay. So I know you have some interesting users because you mentioned Oracle in the website. We can see other examples. I also know that SQLite is used by some other databases like ActorDB and other, which is...
I didn't know that.
You don't know that? Now you know.
I know, yeah. Every time I talk to somebody, I find some new use case for SQLite that I didn't know about, so that's not surprising.
Yeah, apparently they use it for the storage part, I think. And there is also another database which is called the SQLite, which basically is like distributed SQLite.
Oh yeah, they were doing yeah, I've heard that where there's a couple of those around, and they're using Oosterhout's oh, the name escapes me now. The Oosterhout's protocol for consensus. What is his Oosterhout's consensus protocol has a name, and I just don't remember.
Raft, probably.
Yes, that Raft. It uses Oosterhout's Raft consensus protocol, and uses that to distribute SQLite amongst multiple machines. And I've seen that, and it looks really cool. I'm glad that they found the core SQLite useful.
Yeah, actually, the question was, okay, you said there are only 2 committers, but I was curious if you also interact with these people, with this project using SQLite.
Those, no. I did not know that they were using it. But, I mean, maybe I have interacted with them, like on the SQLite forum, and just didn't know what they were doing.
Okay.
That happens a lot. People do stuff, and you know, and a lot of times I'll run across somebody, and you know, they've been working for some big company and doing something really important with SQLite, and we've been interacting with them for years on the forum or the mailing list, but they've been using their Gmail account, and then suddenly we start talking to them in a business setting. Oh, so this is what you've been talking to us about these past 5 years. Now we know, yeah. So it could well be that they've been working closely with us, and we don't know it. I don't know.
Okay, interesting. We are almost out of time, but there are a couple of things I would like to ask before closing the interview. One is about the license. So SQLite is public domain, right?
Right.
And I was curious to ask you the reason for this choice.
Okay, well, that's a long story. So it started out, when I first started doing this, I used the GDBM storage engine, which is a key value store, which is GPL, not GPL. And so SQLite version 1 did that. And so obviously SQLite 1 had to be GPL because it was linking against a GPL product. So, but that's a key value store, and I wanted to be able to do range queries. So I rewrote the storage engine and did my own B-tree-based storage engine and for SQLite 2. And at that point, I said, well, I can relicense this now, make it more liberal license. What should I do? And at that time, it was either GPL or the X license, and then the Berkeley license. And I thought, well, what are these others? And they're the X11 license or the Berkeley license. Those are kind of what everything was using. We didn't have this proliferation of licenses back then. And I said, well, look, what's the point of that? Why don't we just say public domain and be done with it? And that's what I did. Now, I did not know at that time, because I've lived in the United States my whole life, that there are jurisdictions in the world that do not recognize the public domain as readily as they do in countries whose law system is kind of based on British common law. And so I did not recognize that public domain would cause problems for people. And by the time that recognition was brought to my attention, it was so well established that SQLite was public domain. We were just going to leave it like that. It's sort of a thing. And we've gone through the paperwork now to make sure that every single byte of the code is written by one of the core committers, by me or Dan or Joe, or there's a few other people who have contributed over the years. But we have, signed paperwork from all of these people in a fire safe right over there that dedicates their work to the public domain. And one of the downsides of this is we cannot accept contributions from the public at large.
Okay.
Because there's a big paperwork process you have to go through. And in particular, depending on whom you ask, residents of some countries in Europe may or may not be able to contribute their work to the public domain. Depends on whom you ask. You can find lawyers that'll tell you give you both answers, but we're just not going to risk it. I mean, if you live or are a citizen of certain European countries, we're just not going to take your code. Sorry. Because we protect the public domain status, we want everybody to be able to use it freely for anything they want without having to tell us about it. And in order to do that, we need to keep very precise records of who is contributing to the code. And so 99% of the code comes from me and Dan. Okay. There's just a few bytes here and there from other places.
Okay.
And that's all very carefully documented. So that's the story behind public domain.
Okay. Yeah. No, that's something very interesting to know, actually.
Yeah.
Okay. Before the final question, we were talking about the users of SQLite. DB Demon writes in the chat that it's also embedded in Proxy SQL, which is open source proxy for MySQL. And that's right. And this reminds me that it's also used by Orchestrator, which is a tool to manage the topology of MySQL masters and slaves. That's
interesting to know. I did not know that.
So it's funny, but it's true that probably most MySQL DBAs use SQLite without knowing that.
That's really good to know. I like that.
So, and the final question is, I hope not too painful. It's about the code of conduct, because some years ago, I don't remember exactly when, you introduced a code of conduct, which is basically
controversial.
Yeah, controversial, because most of the things I totally agree, and I think it's very difficult to disagree. But there are probably two problems. One is that there are references to religion, and another one is that it's probably too strict for a software code of conduct.
All right. So, well, this came about because certain companies, as a condition for doing business, require that you're the company they're working with. And see, SQLite is developed under a corporate umbrella. There's a corporation. And has a corporation behind it. And so people would come, our support customers, they're doing business to business transactions. And as a condition for doing business, they have to see the code of conduct for the corporation they're doing business with. So, and we didn't have one. So I shopped around for what can we make as our code of conduct? and I looked at a lot of things and a lot of things. And but I'd done a study of this years ago, and I mean, I looked. One of the contenders, for example, was Benjamin Franklin's 13 Rules for Living. I don't know if you've ever read the autobiography of Benjamin Franklin. It's worth a read. But stuff like that. I was doing strange stuff. I looked at the Code of Hammurabi. That was totally inappropriate for software development. But I finally settled on that the Instruments of Good Works, which was an article written by Saint Benedict, and that worked out really well. But it was just a little thing. It was a spot on the website. This is not something that was enforced. It was a spot on the website where I could send companies that insisted on seeing our code of conduct.
Okay.
And it was there, and it was there for a long time, and nobody noticed it. And then some shall we say zealots noticed it and there was a Twitter storm about it, and we had to make other arrangements. So the code of conduct is still there.
Okay.
Had to be renamed.
Okay.
And now it's on a link that I don't publish. So I can still send it to companies that insist on seeing a code of conduct, but it can't be found by search engine robots.
Yeah.
So this was and so people, I don't really understand the problem here. People were really upset. A lot of people feel like that, with open source. See, SQLite is open source. You can do anything you want with the source code, but it is not open contribution.
Yeah.
Because it is in the public domain, you're not allowed to contribute to the core SQLite. And you can make a copy and fork it and do whatever you want. That's fine. But we're not going to accept your patches. And that's not because your patches are inferior or that you're a bad person or anything. It's just we're not going to do that. So, and so, don't be offended by that. But some people don't really understand that. They feel like that with open source, that means I have the right to change it in any way I want. And they got really upset about this. And so we had to make some adjustments.
Okay. No, I hope
nothing really changed. It was a matter of nothing changed in the way we governed the project. And the rules of St. Benedict are good things by which to live your life. I mean, even if you don't want to follow all of the God language, there are still good rules there, and you should read that and learn it and study it. It's a good thing.
They're good rules. The ones about religion probably are more controversial because someone can disagree and prefer another god, or maybe no god.
Leave those out.
Yeah. No, but
and in the preface, I said as much.
But your answer is interesting because it's actually a very important point. It is open source. You are free to fork it. And this doesn't mean that we have to work together. You are totally free to say, okay, no, I don't want to work with you because we have different principles.
Well, that's not why I would reject your code. I would reject your code because your country won't let me release it into the public domain. I mean, talk to your government. We can work this out.
Yeah. And this is another interesting point, actually. Okay, so we exceeded our time because I enjoyed too much to interview you. But there is a question I ask to everyone before closing the interview, which is, given the sad time, we all have a lot of time to read, probably. And can you suggest, can you suggest a couple of books, if possible, one database related and one on any other topic?
2 books, one database fit on one other. Well, what's that in the background? Okay. I don't remember. I've never studied database technology.
Oh, okay. Oh, yeah, you told before.
I wrote the most widely used database engine in the world, and I've never actually studied database technology. You can think about that later.
You can skip that one if you want.
No, I'll give you, but I'm going to give you a computer book. How about this one? Can you read that on the monitor? Do you know
The Mythical Mammoth?
Yes, by Fred Brooks. Have you not read that? This is a classic. It was written in the 70s. It's about software engineering.
Okay.
And it's written in a bygone era. I mean, it talks about flowcharts and things, which are, ancient technology, but all of the principles he talks about are still true today. Mm-hmm. It's a classic. It's a timeless piece. And so I recommend this to everyone who has never read this book.
Great.
And of course, now it uses unfashionable words, man month. These days, we're compelled to say staff month. Okay, but the 1970s was a different era, so we have to overlook these things.
Yeah.
So that's one. Let me put that back. And then, what was the next one supposed to be about?
The next tomorrow, you mean, right?
The next book.
Oh, sorry.
You
The
said
next
2 books.
book should be about anything you like. Could be even narrative if you want.
Okay. I'm going to offer this book. This is it's technically, it's classed under science fiction.
Mm-hmm.
I was assigned this book, and I purchased this book when I was a freshman in college by a history professor, and because it alleged to give us it's a post-apocalyptic novel, but it alleged to give us by reading it, you learn the zeitgeist of the Dark Ages in Europe.
Okay.
I'm not sure. I've come to doubt that claim, but it's still a really great novel. It's a post-apocalyptic novel by Walter Miller, A Canticle for Leibowitz, and it's just a really great read that addresses a lot of very important issues. It was written in the 50s, and so it's assuming a nuclear holocaust. Because see, you're a lot younger than me. When I was growing up in the 60s, maybe you don't know. I mean, everybody just assumed that there was going to be a big nuclear war between the United States and the Soviet Union, and that we were all going to be radioactive. And as little kids, I mean, me and the other boys in the neighborhood, we'd go out in the woods and we'd build fallout shelters. That's what we just did for fun. We just figured that was what was going to happen, and thankfully that didn't work out. But that was just what was in the front of everybody's mind, and so it was written during that era. And a nuclear war has happened, and now people are trying to make sense of the remains of the world, and it's a really, really great novel. So very well written.
Yeah.
So those are my recommendations.
Great. So thank you very much. We heavily exceeded our time again, but it's my fault because I liked it too much.
Okay.
It was a great pleasure. Before saying bye, I want to remind everyone that 2 weeks of databases continue tomorrow with an interview to Konstantin Osipov from ScyllaDB. And we'll finish Friday with an interview with Monty Vidinius, which is MariaDB and MySQL creator. So, again, I enjoyed this interview very much. Thank you.
Thank you so much, Federico, for putting all this together.
Great. So thank you very much, Richard, and see you.
See ya.